And in this session, we're actually going to dive down into a few of these topics to a larger extent than we presented in the keynote. But before we do so, let's quickly take a look at today's presenters in no particular order.
Yeah, that's me. Can you hear me? My name is Esben Kristoffersen. I'm an architect on the compiler and tools team in Copenhagen.
Oh yeah, that's me. My name is Wael. I'm on the application teams, and I'm also part of the security team in Business Central.
My name is Alex Toder. I am the lead of the team that is developing the AL language and development tools, and I've been working with Esben on paving this road to AL.
Yeah, and I saved the best for last. That's me. My name is Jesper. I'm also a senior engineering manager on a team working on the system application. So that's what I'm going to be talking a little bit more about later. So, the road from CAL to AL. Now, what does that look like? Well, for some in this room, the road might look a little something like that. It's very well hidden under massive amounts of lava, glowing hot. It's hard to see like where to go. Some others of you might be a little bit more advanced. You might sort of kind of know, how to get out of this mess. We're getting there. But where we really want this to go is obviously this. Straight road to paradise. Now make no mistakes, there are obviously a few rocks that we need to clear out of the way, and that's why we're here today. We're trying to address some of these rocks, to pave the way into the new world of AL. Because as you say, difficult roads often lead to beautiful destinations, but it takes a little bit of effort. So a little bit more serious view on the road from CL to AL is probably something like that. Most of us start out with a code customized solution in CAL that we all have in common. We also had that point of origin half a year ago. And there are multiple ways, obviously, to get to AL. The one that we're not going to cover today is the one where you completely re-implement everything from scratch and just discard your old solution. That is an option, but it takes some heavy lifting and some investment. The more likely way that you're going to get to AL is more like this, where you start out by preparing yourself for the move to AL. Now, the AL is a new language, VS Code is a new editor, the entire extensibility model is something that you need to kind of, slowly get into. So what we recommend is, instead of, taking it all the way from the beginning, is to start out strapping out a few add-on extensions one by one, trying to submit a few event requests, trying to see how all of this works, just to get warm with the new editor and the new entire development stack. However, we're not going to focus so much on that in this session because there is plenty of good material out there already. There are some recordings from previous tech days, and there's also a lot of good learning material written by some of you guys. So if you are completely new to this, try to check out the net, you'll find lots of good material. Where we're going to start is how do you convert your CAL solution to AL? So the big bulky thing that is left that is now in CAL, how do you get that into AL? Then up next we'll take a look at this infamous system application that you have heard a little bit about in the keynote already. So what is the system application and how will you uptake it? And then we're going to take a look at, now that you are in this new paradise world of AL, like how do you secure your apps and what other benefits can you reap when you actually made the conversion? So what's the benefit of this entire road? I will start with mentioning one related session, because what this session covers is the move from C-side to NCAL to VS Code and AL, and the change from the monolith application architecture into a modularized and extension architecture. And we're going to talk about the latest additions to AL. What we're not covering is the actual code conversion and the upgrade process. For that, later today, you'll have a session called Using Docker and the Container Helper to Convert Your CAL Solution to an AL Solution, which will be by Freddy and Nicola. So that's later today at 4 o'clock, and I highly recommend going to this session if you're more interested in the actual lifting and how you go about making this transition. I've been told there are whales and crocodiles and mountains and stuff in that session, so it's probably a very good one. So that sums up the agenda. I think we've spoken enough about that. Without further ado, let's jump into the first one. And now we're going to ease up on the pink part for a little bit here for a while. So if it's like, too pinkish, he went for a more white theme.
So in the next 20 minutes, you will learn how to convert your solution from CL to AL, how to avoid the common pitfalls, and how to handle typical errors that might arise during the conversion. And most of you will be coming from a solution that is running on NAV 2018 and earlier. Before you can start the actual conversion process, the first thing you want to do is to perform a technical upgrade and get your solution running on the latest Business Central platform from the latest CU of the spring release. We recommend that you do this step because the tools that you need to convert your solution will be getting regular updates with each CU. These tools, Seaside and TXT2AL, will only be available from this in this release. We also recommend that at this point you perform an application upgrade and you merge the latest application available in the CU into your code base. This has two advantages. First, you'll be able to use the merge tools with which you are familiar for merging CL code, and you will also decrease the difference between your solution and the solution that we released fully on AL this fall. But before we start with the actual code conversion, we should make sure we're prepared and we bring our other artifacts along for the ride. If you have an application that is available in multiple languages, you probably have translations for it. If you have been using multi-language properties in CL code, such as CaptionML, TooltipML, these will be extracted automatically to translation files, to XLIF files, and you will not have to worry about it. If you have been using non-UTF-8 translations or translation files that are compatible with Seaside and which you can import, you should import them at this point in time using the standard tools translate import command, and make sure you compile your solution before starting the conversion process. This will ensure that your translations will again be automatically converted when you convert the code. If you have UTF-8 translations that are used in external TXT files, you will want to do an additional step here to create some helper data for the conversion process. You do this by calling the create language command in FinSQL, which will generate placeholders that we will use later to convert your external TXT files. Once we're done with preparing our translations, we can start and export our solution. While developing the conversion process, we've tried to do two things. First, we wanted to generate code that follows the AL coding guidelines. And second, we wanted to make sure that constructs that were not valid in AL were properly commented out and were taken out of your way. On this, the first step to conversion is exporting to the new syntax. And you do this by either invoking the export to new syntax command using FinSQL, or by using the export nav application object with the export to new syntax switch. This will produce a TXT format that is very similar to the one you know from Seaside, but has some additional benefits that will help us along the conversion process. So date and time literals are in a culture invariant format, not a culture aware format like in Seaside. Object references are by name, not by ID. So the code will be more human readable, and your developers won't have to know the 6,000 objects by heart, by ID. Yes and no literals will be converted to true and false to match the new language. And we will also be converting keywords and method names to have the proper casing, so that the resulting code will follow the AL coding guidelines. Another thing that this step does is inject additional information in the TXT files to help us better process controls and controls on pages. So one of these extra bits of information is the type of the source expression of a control. This is sometimes used to filter out, to comment out properties that we know made no sense. And I will come back to that later when we talk about typical errors. And probably one of the big changes that this step does is assign names to controls and actions. In CAL, IDs were the main point of reference, so developers sometimes skipped giving meaningful names to controls and actions on a page. But in AL, everything has to have a name, and we use Seaside as we ask Seaside for a bit of help to get there by generating unique names for all the actions and controls on a page and preventing unwanted conflicts. And probably the last big important piece of transformation that happens here is that all the identifiers in the code get coded. This is done here so that the next tool can more easily process the information. Seaside already had the information about all the identifiers it had and all the properties, so we're using it to push us along. Once you're done with that, everything that you have to do is call txt to AL, and this will take to use this tool, you only have to specify a source and a target folder. The source folder will have to contain the txt files you have just exported, and the target folder will contain the resulting AL files. Most of the defaults for this tool are set up to do a seamless conversion, but you can also optionally specify a runtime to better fine-tune the AL that will be emitted so that it matches your target runtime. Now, this runtime version here matches the runtime property in app.json, and it's relative to the first release of Business Central as the product. So that means that if you want to map back and forth between this version and the version that you see sometimes in the information page, you add 11. Versioning is hard, as you probably know. But there are some things that you might want to pay attention to that are happening during this conversion phase. So the first important thing is going from .NET declarations in the old style in CAL to the AL type of .NET declarations. In CAL, for every variable, you had to specify the full type name, qualified with the assembly name, version, and everything. And we did not want to do that in AL. So in AL, you define your references in a single place where you specify what assembly you're using, what type you're using, and give it an alias. And then in your code, you can reference it by that more human-readable name. The txt to AL tool goes over your txt files, and whenever it encounters a new type, it keeps track of it and will generate an entry in the resulting AL files. But if you import other modules, like for example, uptaking the system application, those modules can also bring their .NET declarations. And you might want to avoid conflicts between the .NET declarations you're importing and the ones that are generated in this step. To do that, you can use the .NET type prefix option to prefix all the .NET aliases that are generated during conversions to avoid any conflicts with imports from other modules. So if we use that option, we see that the alias is now my XML document, and wherever this is used, it will be my XML document. This is important because XML document for your solution might not be the same XML document that is brought in by some other solution, and the compiler will give you an error, and it's better to just avoid it. As I mentioned in the beginning, multi-language properties are automatically converted to single language properties. So from caption ML and tooltip ML, we go to caption and tooltip, and the actual values are extracted to accompanying XLIF files. Now, if you have the external UTF-8 translations and you've run the create language command, you will want to also enrich the emitted XLIF files with information about the IDs of these translations that were used in Seaside, and the IDs that are used in the new world. This is just to make mapping these resource files easier. So if you use add legacy translation info, what will happen is that the produced XLIF files will contain an additional note containing the ID of the caption in Seaside. And you can take this ID and you can use your existing translation files and create a map and produce new translation files that contain information from both sources. Another tricky part of code to convert is usages of control add-ins. Control add-ins were basically stored as data. They did not have a type in CAL, and there is not enough information in the CAL code to do a proper conversion. The fields that were used control add-ins only had a key that was used to look up the information in a table. When converted to AL, these become user controls with a name and a reference to the type mentioned there, but the compiler will complain that it does not know what Microsoft Dynamics NAV client web page viewer is, and it cannot find the control add-in with that name. To help with this, you need to provide the compiler with the TXT to AL tool with information about what actual .NET type this add-in represents. To do that, you can use the .NET add-ins package switch to specify a path to an AL file containing the declarations of your .NET types that represent custom control add-ins. For example, for the web page viewer, we would have a declaration such as this one, where we specify the assembly, Microsoft Dynamics NAV client web page viewer, and the specific type. And you can see that the actual type that implements the control add-in is called iWebPageViewer. And for the alias of the type, we use the one that we have already used as a lookup in CAL. And of course, we need to specify that this is a control add-in. Now, that's pretty much it. You can now create an app JSON, add it to the root of your project. Make sure to configure the AL package cache path to point to a directory containing the system app. And I want to emphasize one thing here. This is the system app, not the system application app. And as you all know, naming is hard, and we really could not come up with a better name here, sadly. Once you do that, you should also keep in mind to configure the AL assembly probing paths. This is a setting that tells the compiler where to look on your machine for the .NET assemblies that your project is using. That's pretty much it, and now you can compile. And if you do, you'll probably see something like this, a few thousand warnings and a few hundred errors, but you should not panic. The VS Code offers help to navigate through these, and you can use the built-in filter to filter out the errors that the compiler has detected. And you can use the command line compiler and say, specify the error log switch and output all these errors to a JSON file that you can use to better divide and conquer the problems in your project. Now, you might be asking yourself, why are you getting errors? Your solution has been working for so many years, why now? Well, Seaside was quite lenient, and it allowed you to write a lot of sloppy code. With AL, we tried to enforce rules that helped you write better code, cleaner code, and hopefully code that runs on the first try and with no surprises at runtime. What type of errors might you get? Well, most of the time, the AL compiler is trying to save you from runtime exceptions. For example, the AL compiler will detect if you have a case statement with duplicate case lines. And we've all used copy-paste liberally, and this is one of the side effects. This was allowed in Seaside, but what it did was just execute the first case statement it found and ignore the rest. And this allowed us to find a few bugs in our application while performing the conversion. The AL compiler will also tell you about references to missing objects. So in this case, we had an action that was referencing a page that no longer existed. C-side would allow this, it would compile, and then it would fail at runtime in a new and mysterious way. Another instance where we see references to missing objects was in the permissions property, where people gave permissions on tables that were no longer part of the application. The AL compiler will warn you about, will give you an error, and the solution is to go and just remove the invalid references. Now, you might be asking, why are we not doing this during the conversion process, where it would require full knowledge of your solution and any references that you might have, and that would require building another compiler just for the purpose of converting. But we haven't seen that many errors, but it's good to know how to react when you see them. Another big improvement we've made while switching from CAL to AL was the type safety we provide when interacting with .NET. We try to maintain backwards compatibility while enhancing the checks around type conversions, typecasting whenever you pass the .NET value to another. And we've seen a few instances in our application where the type of a variable or parameter did not match at all the type of the value that it was passed in. The AL compiler will warn you about this, and the solution is to figure out what are the proper types. In some cases, this code worked only because both types had one common method, and that was the only one that was called on that code path. But if somebody else tried to touch the code, it would have thrown a runtime exception and people would have been left scratching their heads. Probably one of the big changes we've done with in the AL language, and which we hope will help us evolve the base library and the system, the built-in collection of methods, was how symbols are resolved. So whenever you reference a method or a field in AL, the compiler will start searching for it from the innermost scope going steadily out. In this case, we were referencing the evaluate method, and because there's another evaluate method in this object, it tried to resolve to that. And the AL compiler would say that it could not resolve this method. Now, C-side, on the other hand, had some random lookup patterns for symbols. It might look at the global scope, it might look at local scope. You really had to spend a few years figuring out all its secrets. We try to be explicit, and we think that this will help us extend the base library. So for example, if you have a method called foo in your code, and in CAL we would have introduced a method called foo in the system, we would have broken your code, but no longer. Now your foo will be used independent of whatever we do. Another great feature that C-side had was around .NET types with events. Whenever you set the with events property on a variable of type .NET, stubs were created for all the events, and you could code it, and then if you set the property back to false, the code was not deleted. The code was left in the background because maybe it was just a mistake and you did not want to lose your code. Now this means that during the conversion process, this code comes along for the ride, and the AL compiler will tell you that there's no that the variable being referenced doesn't have the with events attribute. The solution is, in this case, is to simply clean up the code and make sure that you're not losing any IP. Now, another great feature of C-side that has been causing a few problems during the conversion process was its great copy-paste functionality. You could take a field and copy-paste it all over the page. Now, properties that made sense in the initial context, when, for example, the field was of type option, do not make sense in the new context when the field type has changed or some other properties have changed. The AL compiler tries to make sure that all the properties that you're using make sense and will lead to good runtime behavior. So if you try to use an option caption on a field of type text, it will tell you that that's not possible. And the solution in this case is to just delete the property. In certain instances, by using the implicit type that we've seen earlier, we can try to remove some of these properties, but that's not always possible because the txt2al tool needs to work with pure txt files and does not have all the possible information. And decimal places was another property that was often left behind and you will have to remove. Another important check that the compiler does is ensuring that the signature of subscribers and publisher must match exactly. This is done to make sure that the code that you've written in a subscriber actually reflects what the publisher will be communicating to you, and that the developer that is just looking at the subscriber does not get the wrong impression of what that might do. We're also checking that methods annotated with special attributes such as hyperlink handler have a signature that matches what the runtime actually exposes. Seaside was a bit lenient there, and it could allow you to have variables that were of slightly different type, and this could result in unexpected runtime behavior. I think we only found one instance of this, but it's good to know. Sometimes Seaside inserted special conversions in place you would least expect. So for example, the data caption expression is of type text, but it was possible to assign a value of type date or of a different type, and Seaside would insert a magical two-string conversion behind the scenes. We think that this behavior should be explicit and you should be aware of what's happening there. Now, one of the smaller issues that you might encounter is attributes that should be used in test code used outside of a test context. The solution here is simple, just remove the offending attributes. Another interesting check that the compiler does is verify that all the handlers that you specify in the handler functions attribute are present within the object. This ensures that you do not get runtime exceptions or that your tests do not fail because a handler was not found or was not executed. And now for errors that were a bit more subtle. In certain cases, for report columns, the compiler would generate additional entries in your data set. So for example, if you had a column of type decimal, I believe, it would generate another column in the data set called format, with the name of the column followed by format. And this could lead to unexpected behavior during runtime. The AL compiler will give you an error at compile time, and it will instruct you to change the name because the name is reserved. And I don't know how many of you are familiar with this special trick. Do you know if we're referencing a value, an integer, or a string there? So what's happening is that the option type allowed you to use the colon syntax to reference a numerical value within quotes. So you would think that this is an identifier, but it was actually an integer value. We think that this will lead to confusing code, so we do not support this in AL, and you will have to validate to verify your code, and you should not be having numerical values anyway. One of the limitations that we've introduced in AL while looking towards the future was a limit on the length of identifiers. All identifiers need to be at most 120 characters. We enforce this limit because we want to expose these elements through reflection. Reflection by the means of virtual tables with which you might be familiar with. Now Seaside automatically generated certain names based on content. So if you had a label, it would take the whole label text, which if it was a paragraph of law, could be quite lengthy, and converted that to a label name. The solution in this case is just to give it a more human-friendly and also compiler-friendly name. And going back to our path of conversion, we have our CL solution running on the latest Business Central Spring platform. We have converted it to AL. We have an AL solution. We try to compile it, and we'll get compilation errors. Now, what we recommend here is that you go back and fix it in CAL. This will ensure that your existing customers will benefit from the errors that the AL compiler has discovered, and it will also help you maintain that solution for longer. Now, of course, at some point, you will convert to AL, you will get the AL solution, you will compile, and success. You will have a solution running on the latest platform from Wave 2. Now, back to translations, because we said we had some additional information that we want to bring along for the ride. Multi-language properties are converted, not UTF-8 translations are converted. And now for UTF-8 translations that we could not introduce into C-side, we just have to run a script on the TXT files and the XLIF files that the TXT2AL tool has produced, and you will get them merged into an XLIF file that contains all the information needed to get up and running. Now, you might also want to consider converting your profiles, and you should really think how much of them you should convert. And especially looking at existing profiles, it might be difficult to understand from them what they actually did. And I think it's one of the examples that XML is not really a human-readable format. But thankfully, in AL, profiles are first-class citizens. So no more fiddling with XML, no more pains during upgrades. Everything will be compile time checked. And with the Wave 2 release, the profile object has received new properties. Well, the description property was already there, but now it's explicitly just a developer comment like it was for all the other objects. You now have a caption and a caption ML. The caption can be used with XLIF files. Caption ML can be used directly in the code, and this allows you to translate the string that appears for your profile. Profile description can also be translated, and it shows up in the profile window that we've seen in the keynote. And you can also decide if the profile should be enabled or disabled by default. These properties are overwritten in the background. Whenever you switch in the web client, if you switch the profile from enabled to disabled, it will create some AL code on top that will override this property. And you also have a property called promoted that will make sure that the profile is visible in the Role Center Explorer. Now, we get this question a lot, and to understand why this is so, we have to go back to the time when C-side was created, when your workstations look like this, and half of our developer team look like this. And we need to understand the changes that have happened to compilers since then and now. Compilers have gone from simple programs to which you give a simple file, and they gave you back a cryptic diagnostic. You spent another half an hour trying to fix that, to complex pieces of software that support IntelliSense, go-to-reference, find all references, and much more. To support all that, we need to keep the AL compiler as well as the C# compiler keep an in-memory state of your solution and constantly update it. So you are paying for all the features that you get. Now, if you want to trade some of these features for more performance or more responsiveness on your machine, you can disable some of them, such as code analysis, code length, code actions, or you can enable incremental build, which will reuse some of that in-memory state. And of course, you can use RAD for faster development. And that's pretty much it.
All right. If you could get your machine to work again, that would be cool. Yeah, so that was a little information to take in. Let's switch gears a little bit slower here and look at the system application. We're back to the pink theme, by the way. So the uptake of the system application. Now, how do you get started? Well, really, that's one small step for a developer. All you need to do is to add that dependency. And then that's a giant leap for, oh, hang in there. When you do that, you will be broken. So a natural first reaction to like being broken is, of course, why would you do that? And some others in this room might ask, ach nö, warum das denn? Again, others ask, ej, hvorfor gjorde I nu det? Or some other languages that I will not try to even get started with. And allow me to apologize for that in the beginning. Of course, we know it's always a hassle to get broken. And we do recognize the pain that we're inflicting you when we break you. But there is actually a good reason for why we did it in this release. And I will try to get back to that and explain a little bit in more detail what these reasons are. So really, the system application builds upon this quote, or one of them of these. Like, you can't build a great building on a weak foundation. You must have a solid foundation if you're going to have a strong superstructure. So really what we're trying is to reinvent or like recreate a foundation upon which you can develop the business applications of the future. Now, why would we be doing that now? Why did we think this is a good time to start embarking on that mission? Well, in order to explain that, I'll try to explain a little story here. So we'll turn back the time to the year 2016, when everything was an on-premise business. There was no cloud on the sky, if you get that one. So NAV was running on local boxes. You guys would go in, you would code customize it to fit the customer's needs, and everyone would be happy. Now that was all perfect until that spring day in 2016 when these clouds came along. So this was not just a disruption, for Business Central, but for the entire industry. Microsoft, of course, also had to react to this new trend with cloud computing, which is why we came along with the cloud first, mobility first mantra. Now, that really meant that, things were about to change. We had to take Dynamics NAV and push it into the cloud. Now, our first attempt was, how should we put that? Interesting. As NAV, in the way that it used to be, wasn't really capable of running in the cloud. So first of all, NAV being built on a code customization model was really, really hard to build upon. Being in the cloud, you need to have similar code. You can't have every single cluster running some code customized solution. So what you need to do is you need to switch from a code customization model to a code extensibility model, right? And then you need to build on top of the solution that we are developing. Now, that was kind of hard. Still is a little bit challenging. It was also rather hard to evolve the product, as we didn't have the right language constructs. With the C side and with CAL, it was very hard to extend the language to actually evolve the product into being a true cloud solution. So that's also not so good. Then also switching to the cloud means also switching the maintenance model. So we will be going from a model where you guys would go out and help the customer and fix every eventualities to a model where actually Microsoft themselves we have to go in and operate in a DevOps model where we operate the solution ourselves. Again, NAV, not the strongest suit. And last but certainly not least, NAV has always been an expert product. It was built by experts and then explained to people that become experts, which is not really the cloud story. In clouds, it's often you want people to just walk up to the solution, fall in love with it, and then live happily ever after. It's not really what NAV was the strong suit of NAV. So that's why we had to change to become Business Central. And now this release is really a milestone in this journey, going from NAV to Business Central. One reason, obviously, that we now only have one client. You no longer need to think like, oh, how does this work on the Win client? How does this work on the web client? There is only one client to develop for, and that is the experience that you should strive to make excellent. Also, there's no longer different languages, different development environments. It's all AL, it's all Visual Studio Code. So that obviously provides a much purer platform to develop for the cloud for. And also all of this now enables us to start componentizing, to start extending, which in the end is why we decided that this is now the right time to start rebuilding the application from the bottom up, trying to separate the business logic from the system logic, by separating these functionalities out into small modules, which then will make up the system application. Now, with all that talk about modules, what is a module? I'd like to add a few words to that. So basically, a module is just a set of objects. So there's nothing fancy about that. The difference, though, being that the functionality within a module is functionally coherent. So the base app is like one big mess of all kinds of functionality, right? It's hard to describe the purpose of the base app. That's different from a module. A module has one purpose and one purpose only. So the first property of a module then is that it's coherent. So how do you reach this coherence? Well, really, you just take the subset of objects out of the base app, put it in an extension of its own, and there you have it. So why didn't we just call it an extension? Well, because it's not really extending anything. It's kind of like the bottom layer. It's like small, cute modules. And also there are other properties to a module than just being an extension. For instance, modules encapsulate complexity. So that means you will not be able to access the internal implementation of a module. We do that by using the new access modifiers. So the implementation will be marked as access internal. So if you're in a different module or in the base app or in whatever solution, you will not be able to call the modules that are inside. So that, of course, gives us flexibility going forward, because now you can go into that module and change the underlying implementation, or maybe move it into the platform, or do whatever you want with your internal implementation to your likings. But then how do you get access to the module? Well, obviously, we need a facade on top of it. The facade is the public API. That's the one that you guys will be calling. And that's the one thing that we cannot change. Now that facade, in order to make it easy to understand, will be well documented. You'll find XML code documentation in the facade, which then allows you to understand what a module does, and you don't have to go inside the module and actually read the code as it was before in CAL. So quick detour into access modifiers, as these are quite crucial to the concept of modules. You just specify access internal. The definition is that the access property is an access modifier which allows controlling the accessibility level of methods and objects. All right. You can set those on object level. Public being the default, which is as it always has been, but now you can also make an object internal, meaning it is only accessible within a module/extension. You can also set it on the field function level, so you can declare a function to be internal, meaning it is only, only accessible within the module. It can be local, only within the object, or it can be protected, which means that it can only be referenced within the module, or in the table extensions/page extensions. So these are the new access modifiers. Use them wisely. Then there's one more property I'd like to point your attention to, which is also new. It's the extensible property. It's pretty much self-explanatory. It tells you whether you can extend a table/page or not. Now, when you're creating new modules or extensions, you need to think extensibility into the design. So while anyway doing the effort of ripping things apart, try to pay attention that, should this thing be extensible or not? Every once in a while, it might actually be a good idea not to make it extensible. It's not always that you want people to go in and fiddle with the internals of your implementation. But if you make it extensible, then try to think it all the way through. Do provide the right events. Do provide the right interface. Interfaces. And that property, as I said, works on tables, pages, and now also enums. So the advantages of modules we already touched upon in the keynote, but I'm going to sum them up here again. They separate concerns, they have stable, well-documented APIs, and they encapsulate complexity. Also, they have a smaller attack surface, meaning it's much easier to do security analysis on these little modules, rather than having a big, wide-open, bulky app. They are faster to compile, which is very, very nice. So actually the entire system application with its 50 modules takes a couple of seconds to compile and publish. So the development experience is a very different one than if you're trying to compile the base application. Also, this is extremely important. their clear size and purpose allows for code contribution model. So every single module that we're creating is going onto GitHub. You can go in, you can create pull requests, we will happily accept them. And as it was announced in the keynote, you can now also go in and create completely new modules. I'll talk a little bit more about that in a minute. But everything that we do, we're trying to do as open as we possibly can so that you can chip in with your needs. They're also easier to performance monitor, and they allow for individual versioning. So, that with these modules in place, now we could start creating the system application. Basically what we've been doing is we've been extracting one functionality after another out of the base application and then made the base application depend on that module. All these modules together is what we're calling or referring to as the system application. So the idea basically behind the system application is we are trying to get out of your business. So the place where you make your money is with the IP in the business application, maybe not so much in the things that make the system work. So by getting out of your business, we won't be stepping on each other's toes, which is the idea here, and that we will continue to do. So that was the introduction. Now let me jump into GitHub to show you what's out there. All right, that's big enough, I guess. So basically on GitHub, let me zoom out just a little bit. You'll right now find two folders. It's the add-on folder where you'll find all our add-on extensions, and then you will find the modules folder. Now in the modules folder, no surprise, you'll find our modules. There are again some folders, a little bit of a folder structure here. Every single folder ideally has a README which describes the context that you're in that folder. So for instance, now that you're in the modules folder, you'll find the properties of modules down here in the README. If we now go into the system folder, this is where the system application resides. At the bottom, you'll find a diagram of how these little modules individually reference each other and what the purpose of the system application is. On top of that, you will then find all of the modules that we've released so far. Those are updated regularly. We try to make them like as current as possible. So let me try to go into one of these modules just to describe or to show you what that looks like. So if we, for instance, go into cryptography management, this one holds, well, here we go. Here you have the README. Well, this module provides helper functions for encryption and hashing, and so on and so forth. So first there's usually a little description of what the module is for, if you just want to quickly understand what it does. And then further down you'll find the API documentation. So for instance, the cryptography management code unit has a function called encrypt. That one returns plain text as an encrypted value, and this is the syntax. So this you'll find for all the public APIs in the modules. So you no longer have to go in and look into the gory details of every module. You can just read this and you would understand what a module does. Now going forward, of course, we will also at some point have this in VS Code so that when you hover over a function, you will see these descriptions. But we're not quite there yet, but it's in the making. So if we take a little closer look at the source code in here, let's take a look, for instance, at... So usually you'll find two flavors of code units. One is suffixed with impl. That's the implementation. Now the reason why we call these implementation is because these are hidden inside the module and you will never reference them. So those didn't need to have the pretty name, whereas the ones that are in the facade are the ones that you guys will be referencing, so those got the nice names. So if we take a look at the cryptography management code unit here, I can zoom in here, you can see that this one has public access because this is our facade, and then all it does is kind of reference into the implementation with a nice documented public API. So that's what a facade looks like, and which you will find in just about every module that we have out there. If we take a quick look at the implementation code unit, this looks a little bit more something like what you are used to see, like a lot of code, undocumented, goodness, like you probably have seen it before. But this, again, I mean, of course, if you want to understand the internals, then you can read about that, but else we don't have to anymore. Now, interesting about this module is actually that we've received the first pull request. by one of our MVPs, Gunnar. So he said, like, I need this Raindale cryptography functionality as well. So he made a pull request for us, where he added this facade, where now you can have a Raindale provider and do all the encryption there. So again, if you guys have similar missing capabilities in our modules, please do feel free. Just submit a PR and we'll be looking at it, and you'll probably see that in the product within a couple of months. There's one more thing. We are going to retire the CL Open library, as it's not. It kind of competes with this. So if you want to, going forward, have .NET wrappers, you can just create them as modules. I will be blogging about that very soon. I haven't gotten around to it yet, but I have, for instance, made the first little module that is basically just a wrapper. This is the MathMat module. So if we take a look at the facade here, so basically all it does is that it forwards the call to some .NET. Because in the system application, obviously, we have .NET access. In the higher layers of the application, we don't. So if you need some .NET stuff and you would like to, have it added to the product, feel free to create a module and reference that. So one last thing while we are here on GitHub. There is a breaking changes document that I would like to point your attention to. Now, when you've uptaken the system application, as I said, we've made some changes which will break you. Some of them might be as simple as that we've renamed some code units. I'll explain why we did things like that, but the fact is that there are some breaks. But you can go into this breaking changes document and just search for the error, and you will find the solution. So for instance, if you stumble over an error saying assisted setup is inaccessible due to its protection level, well, that's because it was made internal, then the solution is use the appropriate API methods in this code unit instead. And so on and so forth. The list is quite long, as you can see. Well, it's actually very long, and it's getting longer by the day because this is again on GitHub. It's an open document. So if you stumble over something that isn't documented in here, by all means, please make a pull request and add, because then you will help the entire community, resolve these breaking changes. Yeah. So that was on GitHub. So speaking of breaking changes, why did we not do why did we not do non-breaking changes like we promised in the keynote today and like we will do going forward? Why we did not do it like this in this release? Well, that is because ensuring backwards compatibility through deprecation is costly and slows down progress considerably. Now that as such is no problem. I think some of you might actually really would like to see us slowing down a little, take it a little bit easy. But in this case, it was a problem because the system application needed a critical mass to establish itself. If we'd come with like 3 modules and saying like, hey, look at that, this is our system application, you've got 3 modules, nobody would care. I would probably not be standing here talking about it, and chances are the system application would just die a silent death. So we needed to somehow, establish this thing and say like, this is where we want this to go, and then this thing will become a self-runner. It's also the new model that we will have to work under with these side-by-side implementation to retire some old functionality in the base app, and then we create a new module which competes with the functionality. It's quite complex, and also we need, I think, a few more language support, a little bit more language support to make this happen properly. So this is why we kind of, now going forward we will be able to add these because now we're in AL and we can evolve the language much quicker. But that will then allow us to do this side-by-side implementation. This is rather hard at the moment, I would say. And then also, of course, we wanted the modules to be clean, proper examples for you to follow. So yeah, that's why, for instance, sometimes, when a name in an old code unit was camel-cased, we actually did rename it, and it's annoying for you because now you have to go into your code and you have to rename that code unit, to be not camel-cased. But there is a meaning behind the madness. We really wanted these to be shining examples of how modules are in the future. So, how do you participate or request change? Really, there are only 2 ways left. You can go to GitHub, Microsoft, AL Lab Extensions, and then you can submit your pull request. You can ask questions. whatever you like, it will be listening there. And you can go to BC Ideas if you don't want to do it yourself. This is a little bit slower progress. You can, put an idea up there, then you can have your friends vote it up, and maybe at some point we will pick it up for you. But it is important that you let us know what we should focus on next, because we will no longer, just for the sake of architecture, we will no longer extract modules. It will be customer and partner value driven. So we need to know from you what should be the next thing that we extract as modules. We won't be doing it for the fun of it. That completes the system application.
All right. Does my microphone work? Okay, cool. So now that you're going to be writing extensions from now on, I want to talk to you about some tips that will actually help make your extension more secure. And we absolutely follow these tips when we're building extension internally in Microsoft. All right, so let's start with the first thing. Data. So where do you store your data? Obviously in a database in tables, right? That's all right if you are dealing with non-sensitive data. And the reason why is if you are building extension A, and basically you access the database, you access the tables, set, delete, get whatever for records, and that worked great, right? But you have to understand that if someone else is writing extension B, they also have the same access. So what if you have, let's say, some sensitive customer data? So your extension will collect some sensitive data, for example, just an example, some social security number or credit cards. And now you would prefer if you can isolate this data and only your extension will access that, right? So theoretically, it's going to be something like that. So only your extension can isolate, can access this data. So how can you do that? Luckily, we have a feature in Business Central called isolated storage, and that will do that exactly. It will offer total data isolation between extensions, right? So how can you actually use it? So first, how many know about isolated storage? Great. After this, all of you are going to know about it, right? So it's really simple to use. As you can see, you have setter and getter, and you can even set the value as encrypted, and you can check if the secret exists or not, right? And if you can see in the function call, we have something called data scope. So what is data scope? Basically, you can add on top of the extension isolation to make sure that you have extra scoping. So for example, if you set the scope to a user, it will mean that when you store the secret in isolated storage, or sorry, your data in isolated storage, only the current user will be able to retrieve it, right? And if it's a company, then only the current company will be able to retrieve it. And you can even merge and have it like this company in, this user in that company would be able to retrieve that data, right? And bear in mind, no matter what scope you use, the data is also specifically isolated to your extension, all right? Okay, so now what about secrets? What if you have your own secrets? So where can you store that? So I will definitely say you need to use some secret store like Azure Key Vault. So I'm building extension A, and now I want to connect to Azure Key Vault, right? I will need to use some credential for my, let's say I created the service principal, and I would need to connect to that. So I have the credential. How can I do that? So would you hard-code it in the extension? I recommend against that. So don't hard-code secrets in the extension. And we can talk about that after the session as long as you want. So where would you store it? So the first time you're setting up a tenant or that extension in a tenant, you can manually add the data and then have a page, like let's say a setup page, will go and store that in isolated storage, which means that this secret is going to only be accessible to your extension, right? So now I wanted to build like a small prototype to see how would that look like. So let me switch. So I will show you first what I did, and then we can take a quick look at the code. So if I go to custom, so I created a demo page, and in that demo page, I had two actions. First one will open a setup page, and if I open my setup page, you will see I have the information I would need to connect to Azure Key Vault, including the Key Vault name and the service principal creds, right? Obviously, I'm not going to enter this in front of you, so I did it before the session. So let's go back, and I had another button that will basically go fetch a secret from Azure Key Vault. And if I click, you can see it's test secret 1. All right, so for people that have trust issues, I have my Azure Key Vault right here, and I have my example secret. So let's update it now. So coming right now. All right. So if I write the value here, you're not going to see it, so I'll just write it here and paste it there. Okay. So let's say NAV TechDays. Okay. So before it was secret 1 or test secret 1. So if I paste it here, great. Now let me fetch the same secret again. And that's actually, like, using Azure Key Vault in that scenario is a great way for you, if you want to rotate secret, update secret for external service. It's always great, because if you can have, like, let's say 100 tenants that are, fetching data from the Key Vault, you only need to change the data in the Key Vault, right? And let's take a quick look at the code. So basically, this is a page that has two test actions, or sample actions. And this is my setup page. And one great tip, when you have a setup page that you don't want to store the data in any tables, I would totally recommend that you don't base it on a table. So just have some variables and have the field point to a variable. So client ID, for example, is just a text variable that you can see down there, right? And it's really simple, because I was using REST API to connect with Azure Key Vault, so all I needed is to get a token using my credentials, and then just basically get the secret, right? I will publish the code in GitHub, so you can have the sample code if you want to use Azure Key Vault from now on. And I have the sample code unit for using isolated storage that I showed you before, right? Okay. Let's go back. So once you are in the prototype or design phase, it's really highly recommended that you will do a threat model before you go and finish your extension. So why would you do, let's talk first, how can you do a threat model? So you would try to gather your team and people that have some knowledge in security, and you will you will build a data flow diagram for whatever feature or extension you're building, right? And then you gather the team and you try to look in that data flow and see if you have any risk or threat that might happen when you have this extension in production. And then later on, you will try to mitigate it and try to validate the fix. So why would you do that? Yeah, you will potentially fix all the threat and risk before actually going to production, so that would be great. And you will increase the risk awareness and understanding in your team. So in order to give you a quick example, I was trying to build the threat model for what we just did, for that prototype. So that's me. I wanted to build an extension, and I have my service principal creds. And of course, I'm not going to hard code them, so I created a setup page. The setup page will go store them in isolated storage, and then later on, I want to get that secret. So I get the secret from isolated storage. I try to create some functions that will basically go get the secret from Azure Key Vault, and then now that I have the secret, I will use it to do whatever I want, right? So, hold on. So, I want to just give you one tip that Vincent talked about earlier, and also Jesper, basically procedure scope or access modifiers. you have to know that by default in AL, procedures are external, which means any other extension that will take dependency in your extension can actually call that. So you have to mark any extensions that deal with sensitive data or secrets as internal. So if I go back to the threat model that I just did, and now I'm with my team, and someone will point out, hey, you have a get secret function, and if I build an extension B, I can actually go and get your secret. And this is not safe. So what would I do? I will go back and I will add to my all the sensitive function, the internal scope, as you can see on the right. All right, moving on. So now that you have your extension, you're happy with what you built, and you want to submit that. You have to understand, to protect your IP, there's a magical property in app.json called show my code true. Show my code. All right. How many of you know about it? Great. All of you should know about this one. Because by default, it is false. And if you set it to true, this would mean that any other extensions that will take dependency in your extension can load the sample and can look through your code. Or while debugging, they can actually debug into your code, right? And if you're fine with that, that's great. That's fine, right? Also, you need to know when you compile the extension, you create a .f file, and that .f file contains your actual code. It's an archive file, so anybody can open it with any 7z or whatever. So if you want to distribute an extension, you need to make sure, and you don't want anybody to look into your extension, so you need to create a runtime package. And if you have show my code as false, it's not going to include any AL code, it's going to be runtime code, right? And it's just like one-liner, which basically you just invoke. You can try it on your Docker machine. And yeah, this is the link for how you can do it. So my last tip for you, if you decide for some reason to mark show my code true, you're feeling the open source energy and you want to share your code with everyone else, but you still deal with some secret or some sensitive data. There is a declaration for any function or variable called non-debuggable, which means that when someone is trying to debug on a sandbox, they cannot look inside your extension secret, right? So that part of whatever you mark will be skipped during debugging, right?
Okay.
All right.
Thank you. So after the move, I'm so glad that we actually are here now, because I've been working towards a complete AL stack for the last 4.5 years. And one of the reasons why this has been so important for me and for a lot of other people in Microsoft is that it will allow us to evolve the language to provide better extensibility in the base app. And some of the things was actually what Vincent showed in the keynote. So first of all, don't be afraid, it's not turned on. And even if it were, I would probably not be able to find a place where I could get any picture developed from it anymore. And actually this camera here is most likely an evolution over a number of previous iterations. And you can continue to do that for a while, but at some point you need to take a major leap to move forward. And the major leap here for us has been to move the entire stack into AL. It allows us to be more efficient in evolving the language, providing new constructs, without C-side holding us back. We have had the feeling internally for the last couple of years when we are trying to make the base app more extensible, it has been holding us back. C-side has prevented us from moving forward as fast as we would like to do. So this is basically the example that Vincent showed. And there's a number of very important points around this. It's interfaces, which in itself provides a new, excellent way of adding more extensibility for us in the base app and for you in your code bases. But it also is coupled with the enum extensibility, which is also something that we have a ton of requests on. And we have been dragging our feet a bit in actually uptaking that in the base app. And one of the reasons is actually that we have a ton of code, which is basically, if enum is foo, then do something, and then if not anything else, just throw an error. And we will have to go through all that for each of those enums that we or options we change into enums, and make sure that all of this is extensible. But how would we ensure that we, first of all, get all of them, and make sure that it's easy to extend upon? Because if we just used, the one tool we actually had in the toolbox, which is an event, we would have to, for each enum, probably spray a huge number of events all over the base app. You will have to subscribe to all of them and be sure that you get everyone. And if we add a new one in some place where we use that option in the base app, you would also have to know about that. This is something we have tried to solve with this combination of interfaces and enums. First of all, using an interface, it gives a semantic name to all the places where we would use it for a test. One example is the has launch access. Rather than having a if loyalty equals gold, we would actually have this specific if statement is all about whether the member would have launch access. Another important part of it is that when you actually extend it, you will have to supply implementations for all the places, and we can tell you about it. If you add an enum extension and you don't actually implement an interface and supply it, we can tell you this is not going to work, because we rely on you to reply this as well. So we think this is a very good way to evolve our extensibility story. I have another example here, which is basically an imaginary shipping provider. We don't have anything like this yet in the base app, but this is some way we could actually imagine us to implement it. I would start by creating an interface. It would have a method. It could be configure, allow me to configure this specific shipping provider. This is configured basically, have I set it up or not? And then a number of other methods that relates to this particular piece of code. I will then create an enum, a shipping provider enum, and the one we may provide, if we don't provide any other implementation to that base, would be like this. It will contain a none value, basically saying select one, and if there's no one present you can select from, well, this is it. And it's extensible. So our implementation would probably look something like this. Configure, throw an error, is configured, false, and then empty implementations. It's not going to do anything. The beauty about this is, the setup part of it for a default shipping provider, that could be something like this. A simple table, 2 fields, basically a not used primary key, and then just a default shipping provider, which is of this enum type. So whenever I use it, I can basically look up my configuration. I can cast my default shipping provider enum field into an interface, and I can start using my default provider. So the configuration page could look something like this, basically showing only one simple field, default shipping provider, persisted, good to go. So, and then if you or someone who actually have a shipping provider service, in this case my imaginary land, sea and air shipping service, came along, will create an enum extension, adding a value for my specific provider. And I will point to an interface implementation, which will be the LSA shipping provider interface, or implementation of the iShipping interface. And in there, I will have the ability to provide configuration. I can figure out myself how to persist it, and I will probably end up having some implementations of are calling my external web service. So this is one of the ideas of how it can be used. There's probably many others. I think we will see a lot of new ways of doing extensibility using the interface. I'm super excited about that. I think it will be a great addition to what we're already doing. So obsoleting objects. Vincent talked about it. I think Jesper also mentioned it a bit. So this is basically a way of us to warn about changes we're going to do and give you good time to react to it and adapt to an improved base app. We have added obsolete to all the objects and all the extensible object elements, and we have also it's also an attribute on procedures and variables, so you can mark them. Still, we're not removing fields yet from the SQL. They're removed from the schema, so we don't care about them anymore, but they are still in the database, but we plan to fix that, hopefully, for the next release. So, demo. I will switch over here. So, this is Visual Studio Code, you know that. And I have already opened my demo workspace here. And I'm not going to say a lot about workspaces, projects, and dependencies, except for it actually works as you would expect almost all the time, which is super great. And what I can see here is, I actually have a code unit here that has some errors in, so I can quickly navigate to that. And I can see in here I have a bubble sort method, and we all know it's not the most efficient one, but apparently I lack some variables here. Let me just that. It's an integer. I have j as an integer. Hold on, wait a minute. This looks silly. Let's see if we could do it like this instead. So, oops. This looks better. So, small, nice addition. For me, it competes a little bit with interfaces because I have loved to do this for a long time. But actually, bubble sort, it's not the most efficient one, so let's get rid of that. So I will obsolete it. Obsolete, like that. And I think if we here, and this is where I say it works most of the time. A small delay. Actually, without deploying and getting new symbols, my sort app, which consumes the bubble sort, immediately gets the bubble sort is marked for removal. And I think I would say use quick sort instead. So you can see how it works, the project dependency part. It's super nice to work with. And a part of that is actually also that we can deploy multiple extensions at the same time, and it will uninstall and reinstall again if you deploy a base and you have something on top. Super nice and saves a lot of time. So let's look at another demo here. I will just close this and this. I have created my better customer list report here and created a layout for it. And I would actually like to substitute the built-in customer list with my version, which of course is way better. And I remember last year, Alex presented a new event that allowed you to substitute a report. And Even though I was actually presenting with him at the same session, I cannot really remember what it was called, and I can definitely not remember which object it was in. So instead of going through all the base up and figure that out, being an engineer, we decided to do it in another way. So we have added a way to pick enums. So there's a new shortcut saying Shift-Alt-E, which gives you a list of all the enums defined in my current module and all the references. And what I remember from the session last year was something about substitute. Let me see, it's this guy here. So let me pick that one, and it inserts the subscriber for me, so I can just fill it out. Super easy. This, and I can substitute it with my better customer list report. This is the demo part. Let's go back here. So, just a reminder, we have created some stickers. We have noticed that a lot of people put stickers on their laptops, and rather than fighting it, we have tried to embrace it. So we have brought a lot of stickers. They will be in the booth down there. And if you for some reason have a laptop from a competitor or something like that, I mean, get a logo, slap it on, right center, and remind everyone that you are a proud AL developer who builds business software that actually are helping real businesses to thrive. And there's a session tomorrow, just a little bit of advertising because I'm in it. I have brought a Lego robot, and I'll try to convince it to dance on the command of Business Central. So if you're interested in that, join that session. And I think we have a few minutes left for Q&A. So if anyone has questions, now it's time.
First one to ask, we get a t-shirt. Goodie. Which one first, the mic or the t-shirt?
So is it working? Yeah, it's working. So I was wondering, do you plan to extend the feature of the interfaces for some kind of, I can pass in a generic object?
We plan to evolve it. Right now, we use it as a foundation for the enum extensibility. We will evolve it, but right now we focus on a plain simple interface put on code units for methods.
I think just one question. Sorry, one interface. So one code unit can implement one interface only, correct?
No, we can implement multiple.
Because all the examples currently that have been shown is one code unit, one interface, one code unit, one interface.
Yes, but you can implement as a list, so you can implement more than one.
So then there's no question, because my question was about, so what about licensing? So do I have to buy additional license just to implement every single interface?
Oh, it's a licensing question. Oh, yes, related to the code units, yes, you can implement more interfaces with the same code unit. So.
Thank you.
Anybody else?
I think one in the back first, I think.
Oh, I think she was first, so she can have first. And I can do it.
Yeah, I was wondering before you showed how great it is to convert XLIF files, but do you plan on tooling to maintain them? Because once you have them and start developing, and especially when you have an add-on you develop in the C side, then you develop it in the AL and want to bring the stuff together, and right now it's quite tricky to merge those files again.
Yes. So, can you hear me?
No, give you the...
Can you hear me? No. Okay, I'll try this one. So it's a good question. Right now there's tooling available, open source tooling, and also tooling provided by Microsoft for managing your XLIF files. We are planning on improving the experience of working with these files, but what our current recommendation is to take out these files from your development process. When you're doing development, you should care only about the code, and once you're done, build your project, generate the XLIF file, send it off to translation, and only include the translated files when you're ready to ship, so that you don't spend your time merging XML files. Also, these resource files are quite difficult to maintain in Git. You should not be spending your time around that, but we will follow up with a blog post on how to use the current tooling and open source tooling available out there. And I know there are currently a few languages in the VS Code marketplace that offer some nice commands for working with them. But we will follow up with a blog post. Oh, sorry.
Right, so my question is, you mentioned that we can create pull requests now for the next time when we want an event request. Can we do the same instead of creating an issue, or it's only available for the system app?
Yeah, so for the system app, definitely you can create pull requests. So if you need something, anything in the system app, go ahead, do pull requests. The base app, we can't open source quite yet. The problem being the second we would open source the base application, it would get ripped into 1,000 different directions, and we probably would not be able to deal with the incoming amount of pull requests. Because, I mean, also let's face it, not every pull request is maybe, the right way to do it, so we actually need some people to look at, the actual content of the pull request. So this is why we're still working, and I would be very interested in talking to you guys, like catch me somewhere out there, like how can we move forward with the base application and the project of kind of open sourcing that, and then enable a closer collaboration on the base application. But for now, you'll have to settle with all the extensions that we ripped out of it as a true open source model.
It might also be a good idea to, before you send out the pull request and you start writing code, open an issue there and start discussing it. You don't want to start writing code and go in a totally wrong direction. It's good to start a discussion early before you've already written code. Anybody else? Sorry, I can't see. Oh, thank you.
It's about the interfaces again. You told about that it's planned for the extensibility of the enums. A nice feature would be some kind of dependency injection for testing or for making the code more flexible. We have to put those ideas that they will be the next step you take, or are you planning those steps already?
First of all, we need to finish the feature. It's in the making. I hope, and that's probably more for Jesper, and I know he is very excited about it, that the app will uptake this for at least probably in the beginning, because otherwise it will be breaking. New extensibility areas in the base app, which will allow you to provide interfaces. But again, we will have to make sure that we are not breaking you while adding this. So, but yes, we are going to use it. So I don't think I can pinpoint more exactly where we will end up using it.
Interfaces only contain the definitions of the functions typically. Are there any plans to allow it to actually have code to execute within it? Or maybe then down the line, is there going to be inheritance perhaps?
There's no plans for adding code to the interfaces. Maybe down the line we will have inheritance and maybe not necessarily on top of the existing objects. We have no specific plans for that right now. But in the case of, I think, the code on the interface, I think that goes a little bit, assume the background for that question is something about defaulting. In the case of the enums, there is actually a way of, on the enum itself, to provide a default implementation for the interfaces. So unless you specify a specific interface for a value, you will hit the default one. Does that make sense? Good.
I think we're out of time.
Yeah.
Thanks for listening in.